But it's also not that way on the x-axis.
Oh, this is what we were doing yesterday.
We are asking what they are, and you have to say
Yesterday it was easy, it was like
2, x equals negative 3, x equals 0. I don't know how to do
I might go like this time.
Wow. Yeah, but I just
Yeah, I thought it was just, I was thinking of multiplicity, like, completely, if you're the same, it doesn't matter how much one.
Hey guys, about to collect this form.
hold on, let me come out here.
Hey, man. Go ahead. Being an irrational number. That's the word.
Okay guys, so the first thing we had for our bell ringers, we were given this equation for a function and we're asked what was the degree for this function. So we have a pretty split response here. A lot of people said 3, a good chunk of people are saying 6, degree 3, and we have also a few people saying degree 2. So if you said degree 3, why did you say degree 3?
Because 3 x's and 3 zeros.
Okay, so we have 3 x's, 3 zeros. What do our zeros come from?
7 x's and 0.
Okay, so let me ask you guys this. If you said it was a degree 6, why did you say that? Okay, what tells you about the multiplicities of those zeros, Chloe? Or anybody? What tells me about how many times a zero, well I know it's the multiplicity, but what tells me that multiplicity? Like from the equation, what can I look at? Let me ask you this. What's one of the zeros from this function?
0.
Okay, so we have a 0 at x equals 2, right? But then remember we had to say how many times it occurred, which is the multiplicity. What told me what that multiplicity was? The square, or whatever that exponent is, okay? So then I'd want to say what?
Multiplicity.
Right, with the multiplicity. And this kind of gets into that second question that you've answered about what are the zeros and what their multiplicities are. Okay, so what degree is this function?
6.
Okay, degree 6. Does everybody see that? Okay, so remember the degree of a function tells us about, do you remember when we talked about the fundamental theorem of algebra? And it said that the number of zeros is equal to the degree, including their multiplicities. So we can kind of determine the degree from considering what our zeros would be and adding like with their multiplicities. So like I have 1, 2, and then 2 from here, and then 2 from here. So that's 6 zeros in total, meaning that I'd also have a degree 6 polynomial. Okay, does that help a little bit? Okay. So then, just kind of continuing on, it asks us about the zeros and their multiplicities. So we've already determined what one of them was. Let's see. The other two would be what, guys? -3 and 0. Okay, so this. Okay, yeah, so a lot of people, you guys seem pretty comfortable with like identifying the zeros from the equations. I will say one of the things I noticed in the last class would be when they saw this x squared, they were saying we have a 0 at x. Is that right, or how can we improve that statement? If it, like looking at this would give me a 0 where? If this factor gives me a 0 at -3, where's this one going to happen at? Okay, so it's happening at 0, it's not happening at x. Okay, just being more clear about that. And then our last question kind of is going to jump us off where we left yesterday. It says consider the leftmost 0. Okay, where am I looking at on the graph? What 0? X equals
0.
Okay, so let's look at x equals 1, and then wants everything to the left of it. So then we have to decide, okay, the product of this factor and this factor on this side of the 0, is it going to be positive, negative, 0, or none? None. I don't think that's an option.
Negative.
Okay, where are you guys getting negative from?
There's one going down.
Okay, do y'all understand why we can say that this function, this red function is positive and this blue one is negative? Because we're talking, remember when we split the graph into 3 regions based off of what the 0, oh god, it needs to be based off of the zeros, not the axes. So if I split it up into regions, then everything on to the left is what I'm looking at to determine what that product's going to be, okay? So this one we said is, so making it negative, because all the outputs would be negative, and all these outputs are going to be positive, okay? So that product's going to be negative. But what about this middle, what if it asked you about this middle region? What would the product of these factors give you? Okay, do y'all see that? Tell me if you don't see that. I can explain it more. Okay, thank you. Okay, T, so we're looking in between, which we're going to go back into this. We're looking in between these 2 zeros. Because remember, what we're doing here is it gives us our linear factors that we can, that multiplication that we're doing with them is essentially we're dilating them to create what kind of function? What kind of function do we create by dilating 2 linear factors? Quadratic, because we're multiplying a degree 1 times a degree 1, which is what we're doing here. So you know you're going to be looking for some parabola, right? Well, you're multiplying the output values of your linear functions. So the blue one is gonna have positive or negative output values in this region. Well, so notice how in between my two zeros, both the red and the blue are underneath that axis, right? Which is gonna make them what? It's gonna make those outputs negative because all my y values underneath this x-axis are negative. So when I multiply negative times a negative, I'm gonna get an output that's positive. So when I graph that new output point for the product, it's gonna be somewhere up here, right? Because we would keep that same x value and then plot our new y value, which is like what we're kind of starting to go into today. Does that help, Casey?
It does.
So can I ask you, what would the product be in the rightmost region? So on this side, this factor is what, positive or negative? And then this one's positive or negative. So what would that product be? Okay. Everyone else good on that? All right. So let's get our notes out. We're going to continue where we left off yesterday. So, what's up? No.
I keep zoning out, he's talking about you. I'm trying to stay focused. I didn't get a lot of sleep last night. I woke up like 3 o'clock in the morning.
What page is this? 171?
No.
171? Okay, guys. Caleb, where's your book? Get it out. Okay, guys. So remember yesterday, so kind of how we talked about, we're looking at this idea of using the graph to create the new function, not the calculators, right? So we have to understand, that's why we're splitting it into regions and then analyzing like what's going on in each region to determine, okay, what's this product going to be. So what I want you to notice and what we're going to do is going to really, it set it up for us. This already split into 3 regions, and looking under like question 2, 3, it's saying, okay, well in each region, what's the product going to look like? What are these x values going to produce? And it's going to ask you to graph the new function. Okay, well then the next question is going to say, graph the product of these 2 linear functions. So you have to apply, okay, what are the zeros? How can I split this graph into different regions and then analyze those parts? So as we're going through this, make note of these processes and these like ideas that we're doing so we can apply it later. And that's going to help us understand this stuff better. So remember, we split this graph into 3 regions based off of these zeros. Okay, I think we got a little bit further than that in this class. So then we're on this in this class.
Cut you off at the end. Yeah.
Okay. We're on 3. Okay, that's right. I remember we left off. So remember, we've decided that we can go over this real quick because we just did it in our bell ringer. David, in region A, is the product of these factors going to be positive, negative, 0? What do you think? Yeah, region A, the product of these factors. Do you guys agree with him? So when we're talking about region A, KT, so it labeled it up here for us. So like region A is all this.
Negative?
Yeah, so can you tell me why it's negative?
Positive times negative.
Right, because it'd be these positives times these negative values. Okay, Tracy, what would our product be in region B?
Positive.
Okay. Jackeen, do you understand why it would be positive there in region B?
Because it's, the negative sounds are positive.
Well, let's look at region B. We're looking at this range of outputs. So like between here and here, notice how both of my outputs of these factors are going to be positive. Do you see that?
No.
You wanna come up here? I'll show you. So guys, something else I kind of told the last class is when you're looking at these regions, look at your paper and use your pencil and trace the lines with your fingers. So we're looking at region B. So that's everything in between these two lines, right? So we're trying to ask ourselves, are these outputs in between here positive or are they negative? Right, they're both positive because we're talking about the outputs, we're talking about these y values. So for all the x values in between these regions, we have positive y values for both of the functions. So when we multiply those together, we get a positive number, okay? Thank you. Does everyone else see that too?
Yeah.
So, Jaquan, what would the product be in region C? What are we multiplying in region C? So we're multiplying these positive outputs by what? These negative outputs, giving us what kind of product? Giving us what kind of product? A negative product. Okay, and then we chose x values in each. Have we done that part? Have we chose x values in each region and evaluated them? Okay, so the reason we're doing that is, let's see. Chloe, what x value did you guys choose in region A?
1. That's not right. Oh, I didn't do A. I did C and B. I didn't do
Okay, let's do, Jaden, what x value do y'all choose for A, region A? Okay, so we need to do this one, it looks like. Well, no, okay, look guys, so in 2B, what you have to do is for each region, so we have to split this up, region A, region B, region C. You're choosing an x value, which I know some people have done some of the regions, but everybody needs to do all 3 regions, okay? Choose an x value in each region. So in region A, what's something I can pick?
-2.
Okay, -2 works, something else. -4 works, something else. Okay? In region B, I need to pick an x value in here, and I pick an x value in here. So if I pick -2 for A, what does it tell you to evaluate? H of x,
L of x and H of x times
L of x, and the product of the two. So you have to show me 3 things in each region. Okay, so this is how we said, okay, well this is positive, this is negative, it's going to give me a negative. Now we're actually putting numbers to that, a positive number and a negative number to actually give me a negative number that I can put on that graph. Okay, because the things you're graphing, that's how we're getting that new function. That's where we're creating that quadratic. So, remember we kind of talked about yesterday, this graph's not all nice and pretty for us to just look. We can't look at every h of x and say, okay, at 6, or at, or at the L of x and say, no, because the h of x is x, so that one's fine. But the L of x, we can't look at 6 and I don't know what y value that is. So what can I use to help me figure that out?
Calculator.
I don't know where negative 1.5 comes from. What am I going to put in my calculator? What am I substituting? Substituting into what? How do I know, where do I get it from? How do I know what these lines represent? We wrote it down yesterday. What are they? Okay, y'all see that? In your textbook it says h of x equals x. Okay, let's go over this real quick because it was a big deal in first block. If I'm trying to find my h of x in region B, okay, and I choose an x value of 2, what is the h of 2 gonna be?
2.
Okay, it's not gonna be -2, or, I don't know, it's 2. Whatever x value you choose. Okay, so then, what does it tell you that L of x is equal to?
2x.
Okay, negative 2x
Plus 8.5.
plus 8.5. Okay, and then you also have to find the product of these two. So, once you find your h of x and your L of x, to find their product, what do we need to do? We're going to multiply to find the product. Okay, so for each region, guys, we should have 3 values written down, and then it wants you to graph the product, or plot the point of that product. So what you're going to do is,
So we're gonna multiply 2 times negative 2x.
right, but you don't even have to use the x because you'll know what these are actually equal to, so you can just multiply those. But then remember, that's what you'll be plotting on here. So like at x equals 2, you'll plot whatever product of that times that, be somewhere up there. Something like that, okay? But go through this process first and find these values. But I know we're pretty far in this, so finish what you haven't done yet. Start looking at number 3. If you have questions, let me know. Okay, so then you get it right. Well, no, you don't have it. We didn't finish it because you don't have A, B, C, and you don't have 3 values for A, B, and C. Okay, so yesterday, what x values did we use for this? 3, okay, so 3 is in region B. Okay, so you found some values that work for region B. You need to do that for A, and you also need to do it for C. Because doing it in each region helps us plot points in the region to make our graph. So that's kind of like winter sign, like, okay, it's going to be positive over here in this region. You're kind of planning, like, where it's going to go through. What? Well, it depends. In A, what region A, what x value?
What is this point right here?
Okay, so just use -2, then it'd be, yeah, so the L of x would be 4.5, is that what you're saying? Okay, so then what would the product of
Okay, it's a 0.
L of x and H of x be? No, you don't have to redo anything, because you already know what that equals, and you already know what that equals. So when it asks for their product, you just gotta multiply.
That's what I got for A.
Yes, okay, so you did this for region B, so she's doing it for region A. So in your groups, make sure you guys all have the information, and then do it for a value together in region C. Does that make sense? Okay. Okay, so when you plotted, okay, this is you're the product, right? This was the product when x is equal to what? 2? Okay, so the point you would plot, keep the same x value, and then you found your new output. So then from there, that's how we can create that new graph, and you'll find. You can kind of see how it's going to do that.
So
Because oftentimes negative is negative, so it's going to be negative, negative, and then it'll start turning positive down here. Not necessarily. No, because the point of it, I think it's going to be above this, where they intersect. Yeah.
line cut off the intersection.
Yeah, the zeros make the regions, divide it into regions. Y'all good?
So when it leaves the line.
Are you confused about the regions? Okay, yeah, that's fine. So, I think I know what you're talking about. Hold on.
Do it.
You do, okay.
I can't play my sport. You can play my sport.
Okay,
You
so,
got the whole team.
So you'll be maybe
this is already been A, because it's on this side of the right? Okay. And then it's everything on this side of, because so you see this is crossing the x-axis here, that's why they draw that line. Okay, and
I
then,
don't understand that said the exact same thing he said. Wait, I'm still getting.
hold on. Okay, so that would be region C, and everything in the middle is D. What line? Because that's where this is crossing the x-axis. So every time it crosses the x-axis, I'm splitting my thing up into regions. So we drew these, we drew the linear functions first, right? Then from there we said, okay, where does it cross the x-axis at? And then we can divide it. So those black lines came first and then the purple dot ones. Okay. Can you see it a little bit better that way? Use color pencils if you need. Yes.
I
I can't help but stick a point.
Like 10 times.
You can look at me and tell me what's in D. Pick one.
Now watch it.
What's the x value in D? Region B. Okay guys, let me get your attention up here real quick. Let's go over like what we're supposed to be plotting. So, did anybody continue to use this A value of -2? I mean, yes? Okay, if you use that, so your H of -2 is going to be what? -2, and then your L of -2 was what?
12.5.
Is that what y'all got? 12.5 for the L of -2? Okay. So then what did you get for their product? You get negative, sorry, what? So, okay, so then what does that -25 tell me? Where would I plot a point at based off of that information?
Oh, you bet.
Huh?
On the other line.
If I'm plotting a point, then I need a coordinate to put it. I need an x value and a y value. Where's it going? Okay, so this point that I'd plot would be at -2, -25. Where's my -2 come from? The x value that you chose. Where's the y value come from? That product, because isn't that what we're doing? Didn't we predict that the output in this region was going to be negative?
Yes.
So all these things are lining up for us, right? Okay, so I guess we can't really plot that one, but it would be like way down here. So did anyone do a -1 in A region? Okay, that's fine. Keep working. I just want to show you that part. So number 3, let's talk about number 3 really quick. Also, it asks you to describe the product at the point of intersection of the two lines. So where they intersect, how am I going to figure out what the product of that is? What am I going to be multiplying? Okay, it's a positive times a positive, but how do I know what values to multiply? Okay, so for this one, also notice number 3 actually just tells us to describe how to get that product. So tell me what values would we have to multiply from this point? Well, what do I know about the values from these two lines? Well, yeah, they're both positive, but is there anything else similar about them? They intersect. So what does that mean for these x values? They're the same. What about the y values? So what am I going to have to do to get that product? Multiply by itself, which is the same thing as squaring it, okay? So for number 3, I'll just go ahead and write out here because I want to keep that number 2 up. But in number 3, we can just write, to square the y value at the point of intersection. Since they're equal, so I'll let y'all write that and then we'll see what that would look like on our graph. What? So y'all got that? So where I know, okay, so this point's not like on the crossing points of this grid, but we can say it's like about 3, right? So what would that new output be, approximately? 9. Like it's going to be whatever it actually is squared. Okay, so we'd square 2.83, so then that's what the x value would be, right? So because I keep it there, my new point of intersection would be somewhere up here, right? That's also kind of like my positive times my positive. Do y'all have any questions about that? Okay, so do y'all need some more time to finish this part, or do y'all have this?
We have it.
I need to know from everybody. Do you need more time to finish this? You do? Okay. So let's do this. Take a few minutes, finish. For the groups that need to finish this B or 2B, finish 2B, the calculations. But then other groups, since we've already talked about number 3, start thinking about number 4. It's just asking you about, what do these zeros mean of the 2 linear functions. Also, guys, we will be starting our understanding check at 10:30. So keep that in mind, but continue working in your groups on that question 2. If you finished 2 and you've plotted some points for those x values, go ahead and to number 4.